Okay, these are solutions to the last two problems on the whiteboard review. And in these problems, we have to think about what it means to add or subtract vectors geometrically. So the first one says, write a vector or vector expression that is equivalent to the one given. So we're asked to look at vector k plus vector g. So I'm going to go ahead and highlight those two vectors. So this is vector k. I'm highlighting that in yellow. And this is vector g, which I highlighted in red. And the sum of those two vectors is going to be starting where k begins and ending where g ends. So I'm going to actually I'll draw that vector in red. So starting where k starts and ending where we end, we get the vector that I just drew in red. And if we look at that vector, we can see it kind of looks like f. It's almost f, but it's going in the opposite direction as f. So that will be negative f. That's what k plus g is. So let's take a look. I'll erase what I drew, and let's take a look at the next problem. Okay, the next example is adding the opposite of vector c plus k. So I'm going to go ahead and highlight the opposite of vector c. So I'm going to start from the terminal point of c and go to its initial. So what I'm drawing in red here is the opposite of c. And to that, we need to add vector k. So that's actually positioned nicely. So I'm going to add the vector k. And now the resultant vector is from where we started to where we ended. So I'm going to draw that here. So we started at this point and we end where k ends. So this is actually the opposite of vector c plus vector k. And that corresponds perfectly with vector h. So that's the answer to letter B. Let's take a look at the next one. All right, the next example wants us to add vector d minus e minus g. So I'm going to start with vector d. So from the initial point of vector d to its terminal point, or from tail to head. Then starting where d ends, so where d ends is right here, we need to add the opposite of vector e. So vector e is going from this point that I'm highlighting to actually the point where d ends, and we need the opposite of e, so we need the vector that goes in the opposite direction. So we're going to start at the terminal point of E and go to its initial point. So onto that, we're going to add the opposite of E. So we have D plus negative E, which is the same thing as D minus E. And then we're going to subtract G. So we need to go along the G vector, but in the opposite direction. So we're going to go in the direction I'm drawing right now. And then the resultant vector is from where we started. So this is where we started to where we ended. So this is start to end. And then we need to connect those points from where we started to where we ended after we went across all the vectors. And so that vector is going to be this vector here that I'm drawing in purple. And that vector corresponds with the vector h. Okay, let's go ahead and do the problems on the lower portion of the page. So I'm going to flip to the next page. And in this one, we say name two vectors in the diagram whose dot product will be negative. Then name two whose dot product is 0. So I'm going to summarize a bit about dot products here. So if the dot product equals 0, then vectors are perpendicular. That's one thing we need to know. The second is if dot product is greater than 0, actually I don't want to write there. So if the dot product is greater than 0, then the angle between the vectors is acute. And the third case is if the dot product is negative, then the angle between the vectors is obtuse. And this is the angle between the vectors. It's different than the direction angle. So there will be multiple answers here. So if we want a negative dot product, all we need to do is find two vectors whose the angle between them is obtuse. So let's say, what if we pick vector A and vector E? That is an obtuse angle. So we know that the dot product, so we know that A dot E will be negative because the angle between them is obtuse. So we have an obtuse angle here. If we want to name one where the dot product is 0, that means that the vectors have to be perpendicular. So here's an example of vectors that are perpendicular. I have the vector D and the vector H, and I know these are perpendicular because this is drawn on a grid. So I know that D dot H equals 0 because D is perpendicular to H. You could also have chosen, let's say, B and K, because those are also perpendicular. So another example could be, we could say B and K, because we could move, remember we can move K from its original position over here. This could also be the vector K. Remember, vectors can be slid around in space as long as they have the same magnitude and direction. So B dot K is also equal to 0 because that vector, those two vectors are perpendicular.